next topic in probability is discrete random variables. Discrete random variables. Now, first of all, what we understand by discrete. Discrete is a quantity which have a discrete values in the scale. In this topic, we are going to look at probability problems in a different way. Now, for example, we had this example back. I repeat it again here to consider it by our new problem, by new way, is that I can make it in a different way, that I have a 3 fair coins. 3 fair coins are going to be tossed. We either get heads or tails. What is the sample space? Therefore, we have 3 fair coins. Either we are going to get 3 heads, or we are going to get 2 heads and 1 tail, or we are going to get 1 head and 2 tails, or we are going to get the 3 tails. We are going to look at this problem by a different way. We are going to choose some variable x. The variable x is the number of heads this variable x will have values of x will have values of x equal 0, 1, or 2, and 3. Therefore, the discrete values of the variable x is called small x. We are going to put this in a table. That table will write down the possible values of x and the probability that capital X equals this small value x. The variable capital X can have values of 0, 1, 2, and 3. What are the probabilities? We can get the answer to this question from what we got there for above. What is the probability that x equals 0? Means the number of heads is zeros. The number of heads is zeros is the last one. Therefore, it is one case out of 8. The probability is 1 over 8. Then we look at there is one head, 1, 2, 3. It is 3 over 8. Then 2 heads is 3 over 8. Then 3 heads is 1 over 8. There's one importance point here in all problems, that sigma probabilities equal 1. If you add up all probabilities, the sum should be 1, because we covered all the cases. What do we call this table? This table is called probability distribution, probability function distribution. Well, not like when we have frequency distribution table. This is a probability distribution table. This table is called probability distribution table. We can express this distribution table in a function way by saying that the probability that capital X equals small x is equal to. The probability is 1 over 8 for x equal 0 and 3, and 3 over 8 when x equal 1 and 2, and 0 otherwise, to show that there is no other possibility. What this is called probability function. Also, there is one more thing, is that we can add to the function, to the table above, x and the cumulative probability. We are going to call the cumulative probability f of x. This is cumulative probability. 0, 1 over 8. 1 is 3 over 8 plus 1 over 8, 4 over 8. 2 is 7 over 8. And 3 is 1. What is that table called? It's called capital F of x. And the meaning of capital F of x means cumulative probability. This is cumulative probability. Is always called F of x, capital F of x, cumulative probability. We'll still be looking at this example again. Therefore, I'm going to remake it again, the table once again. We have a variable x, capital X, and its and corresponding values small x are 0, 1, 2, and 3. And the probability values are 1 over 8, 3 over 8, 3 over 8, and 1 over 8. And we know that sigma p is 1. What does this table give us? It gives us what we call probability. This is probability table distribution, not probability frequency table, no, probability, right, okay. It is, we don't call it, let us say, right, the, what we used to call before is frequency distribution. This is probability distribution table. We call it probability distribution table. In the previous table, frequency distribution table, we have the variable x and the frequency. Then we get what we call the mean value. The same thing here we can do, we can get the mean value. The mean value of x, before we used to say what is the mean value x. Here we say again it is the mean value x. What is the mean value of x? We call it here in this topic expectation, because the mean value means the expected value. Therefore, the mean value is called the expected value, and also we say it called expectation. How are we going to get the mean value? The mean value equal sigma f of x, sigma f of x, sigma f times x is going to be p times x, and instead of f times x, it would be p times x over sigma p. And sigma p is 1. And we call the mean value the expectation. So you say the expectation of x, or the expected value, expectation or expected value. It is sigma px. Therefore, we can get what we call the expected value of x. It is sigma px. Sigma px, in this example, the expectation of x equal 0 times 1 over 8 plus 1 times 3 over 8 plus 2 times 3 over 8 plus 3 times 1 over 8. We add this power up. It's 3 over 8 plus 6 over 8 plus 3 over 8. It is 12 over 8. 12 over 8 is 1.5. From the same philosophy, of getting exactly the terms, the useful terms we used to get before, we can get the variance of x. Exactly the same rule we had before. What was the variance of x? Sigma x squared, right? It is sigma x squared minus sigma x squared, right? Now, our new rule, because sigma p is 1, therefore becomes like this. It is sigma x squared minus the expectation of x squared. The previous rule is modified. Variance used to be called sigma x squared over n. Here n is 1 minus sigma x all squared over n. This new equation for the variance of x, because here we have sigma p is 1. Notice that sigma x squared, right? It's supposed to be sigma x squared p. The variance of x equal sigma x squared p, because before we had the rule of getting sigma fx squared. If you go to the earlier chapter, right, and you find what, later I will prove this for you at the moment. Therefore, we have sigma x squared p minus expectation of x squared. We can say that expectation of x squared, it is similarly sigma x squared p. And therefore, the variance of x is the expectation of x squared minus the expectation of x all squared. In this problem, we get the expectation of x squared. The expectation of x squared is, excluding the 0, 1 squared times 3 over 8, plus 2 squared times 3 over 8, times 3 squared times 1 over 8. Therefore, we get 3 over 8 plus 4 times 3 plus 12 over 8 plus 9 over 8, right? Now, 3 over 8 plus 12 over 8, you have 15 over 8, 15 over 8 plus 9 over 8, 24 over 8 equals 3. Therefore, the variance of x equal 3 minus 1.5 squared. and this will be 0.75. 3 minus 2.25, right, 0.75. This means the standard deviation in this problem, sigma, equal the square root of 0.75. This is all the questions we are going to be asked to solve, all of them. All the type of questions which are going to be asked to get the expectation of x. Then he could ask us to get the expectation of x squared, from which we get the variance of x, and then we can get the standard deviation, the square root of the variance. Now, just to remind you, with what was right earlier, the rules we had about frequency distribution. We had these rules for frequency distribution. Now, we had the rule for variance before, variance for what we call frequency distribution table, the variance equal sigma f x squared over sigma f minus sigma fx over sigma f all square. When this is applied now for the not frequency distribution, probability distribution, we have f replaced by p, and sigma p is 1. Therefore, the variance would be equal to sigma p square px square minus sigma px all square. And this is called the expectation of x square, and this is the expectation of x all square. This is a proof for the rule. Now, one other thing from the previous page, we got values for the following: expectation of x 1.5, the expectation and the variance 0.75. Right. The expectation of x was 1.5 and the variance was 0.75. For the same previous problem, we could be asked to say that x is coded by a variable y, and the variable y equal ax plus b. And we wanted to find what is the expectation of y. Here we have rules. You should remember them. And want to ask you, we wanted the expectation of the new coded variable, but it will be mentioned to you in a different way. What is the expectation? Let's say expectation of y, the expectation of ax plus b. The rules say is a times the expectation of x plus b. And again, if I said to you what is the variance of y, means what is the variance of ax plus b, the answer is a squared times the variance of x. Therefore, you apply these rules whenever you have questions like this. This covers everything you are going to be asked for this new topic. We will take some more examples. Right? Now, let us have another example. A tetrahedral die has 4 faces. 1, 2, 3, 4. The die is a bias die. It's not a fair die. If it was a fair die, then the probability of landing on each face is the same, 1/4, 1/4, 1/4, and so on. But it says here, this is example 5 in the book, tetrahedral die has these numbers. The die is a bias die, such that the probability of the die landing on any number x is k over x. Therefore, we are going to make the table. Now, x can be 1 or 2 or 3 or 4. 1, 2, 3, 4. Probability is k over x. You have k, k over 2, k over 3, and k over 4. We know that the sum of the probabilities is 1. You have k plus k over 2 plus k over 3 plus k over 4 equal 1. Multiply by 12, therefore get 12k plus 6k plus 4k plus 3k equal 12. Right. 18, 22, 25, 25k equal 12. Therefore, the value of k is 12 over 25. Then we make the table, the proper table, and we put the proper values after we found them.
9 o'clock p.m.
Now,
9 o'clock p.m.
x is x is 1, 2, 3, and 4. Probabilities. K, 12 over 25. K over 2 gives us 6 over 25. K over 3 gives us 4 over 25. And 3 over 25. The usual questions is to get the expectation or expected value. What is the expected value? The expected value is expectation of x equal sigma xp. Therefore, it is 1 times 12 over 25 times 2 times 6 over 25 plus 3 times 4 over 25 plus 4 times 3 over 25. The answer is 48 over 25. This is the expectation. Right. We are going to find the value of the variance. To get the variance, we get the value of ex squared. Therefore, it is sigma x squared p. 1 square times 12 over 25 plus 2 square times 4 times 6 over 25 plus 3 square times 4 over 25 plus 4 square times 3 over 25. We calculate this value and we get the value of ex squared. How to get then the variance of x? The variance of x, would be ex squared minus the expectation of x all square. The standard deviation is the square root of variance of x. And this is everything can be asked about the problem. Let us have another example. We are given, this is the next example, example 6. We are given a table. Already a table is given. The table contains a variable x, which can have the values 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And we are given the probability. 0.1, 0.2, 0.3, 0.25, 0.1, and 0.05, and 0.05. It could happen that we can be given one probability is missing, and we can be asked to calculate that probability. Yani we could be given one of these values given, and we are asked to find its value. How? we know that the sum is 1, so therefore we subtract 1 minus the remaining, we get the missing one. Here you are asked simple question, but I just wanted even to go over such simple questions like what is the probability of x greater than 1 less than 5? Probability of x greater than 1 less than 5, yani probability of x is having values which are more than 1 less than 5, which means it is the probability of 2 and 3 and 4. So we add 0.2 plus 0.3 plus 0.25, which the answer is 0.75. Now, another question, it says here, what is the probability of, right, x greater than 3 less or equal 6? This means the probability of 4, 5, and 6. 4 is 0.25 and 5.1 and 6.05. Right, 1.05, 0.15 plus 0.25, 0.4. We can be asked what is the probability that x less than 3. That means a probability of 1 and 2. Therefore, just add 0.1 plus 0.2 is 0.3. Of course, we can be asked the same questions. Exactly, what is the expectation of x? If we ask what is the expectation of x, we say sigma xp. Then, if we asked what is the variance, we get first what we call the expectation of x squared, which is sigma x squared p. Then we can get the variance of x, which is the expectation of x squared minus the expectation of x all square. Then if you ask standard deviation, it's the square root of variance. Typical questions, as we know. Right. We can have a question like this. This question is about what we call the cumulative function. Cumulative function means the function of x. Function of x means cumulative function. This is example here says that discrete random variable has a cumulative distributive function of x. Function of x is given as x plus k over 8, where x is 1, 2, and 3. Cumulative function, this means cumulative, the function of x is a cumulative probability function, is always, you call it f of x. It will have a value 1 for the last value of x, because when x has the last value, the value should be 1. And therefore, we substitute x, the largest value, and the answer is 1. So the largest value of x is, right. The largest value of x is 3. Therefore, 3 plus k over 8 equal 1. Now, then we solve this equation. We are going to get that k, right? We will get the value of k equal 5. It means that f of x, it means that the function f of x equal to x plus 5 over 8. What is the value of f1? Is 1 plus 5 over 8. This is 6 over 8. What is the value of f2? This is 2 plus 5 over 8, which is 7 over 8. What is the value of f3? Taman, of course, is 1. Now we wanted to make the probability distribution. The values we got there, these are the cumulative probability. Of course, when x has the first value, there is no previous value, therefore it is, when x equal 1, the probability is 6 over 8. When x equal 2, we subtract 7 over 8 minus 6 over 8, because f2 is the sum of the probability of 1 and 2. 1 and 2 equals 7 over 8, and probability of 1, 6 over 8. This is 1 over 8. 3, the same thing. It is the probability of the 3 values is 1, and 1 and 2 is 7 over 8, therefore 3 is 1 over 8. Then again, you can be asked to find what is the expectation of x. We say sigma xp. 1 times 6 over 8, 6 over 8. 2 times 1 over 8, 2 over 8. 3 times 1 over 8, 3 over 8. 6 plus 5, it is 11 over 8. And the same thing, we can get the expectation of x squared. It is 1 squared times 6 over 8 plus 2 squared times 1 over 8 plus 3 squared times 1 over 8. After we get the value of ex squared, we can get the value of variance of x as ex squared minus ex whole square. Now we are going to come to one type of right distribution in the discrete. Now, it may happen that we have a case where the distribution is all equal. Means, like when I ask you, we had this before, when I ask you what is the probability of we have a fair six-sided die, what is the probability? The probability of having each face 1 over 6, 1 over 6, 1 over 6. Let us have this example. It is a fair cubical die, right? It is a fair, right, cubical die. We have 6 faces. Now, x could be 1 or 2 or 3 or 4 or 5 or 6. 1, 2, 3, 4, 5, and 6. the probability is 1 over 6, 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 and 1 over 6. Now, if we ask to find what is the expectation of x, we are going to say it is equal to sigma xp. Therefore, we're going to have 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6. We add them up, right? We got the value is adding 1 plus 2 is 3, so let's say 6, 10, 15, 21 over 6. The same answer you could be obtained by a formula. A formula saying this, that the expectation, this distribution is given a name. What is it called? It is called discrete uniform distribution. Discrete uniform distribution. Rather than getting the answer by the usual way, we have a rule. The rules say this: the expectation of x equal n plus 1 over 2. This one is going to come out to 3.5, and the same thing here, the answer is 7 over 2, right? 7 over 2, which is 3.5. This is the easier, of course. There's also an easier equation to get the variance. Rather than getting the variance by the usual way, the variance of x equal sigma x squared p, and we calculate the whole values, right? We are going to get, of course, it will be 1 squared times 1 over 6, 2 squared times 1 over 6, 3 squares times 1 over 6, 4 squares times 1 over 6, 5 squares times 1 over 6, and 6 squared times 1 over 6, which is going to be 1 and 4, 5, 5 and 9, 14, 14, and 4 squares, 16, 30, 30, and 25, 55, and 36, right? We are going to get the value, after we simplify it, is going to be, the answer is exactly the same as if we do the variance. This is the rule, variance of x equal to n plus n minus 1 times n plus 1 over 12. You will get exactly the same answer, which is 5 times 7 over 12, which is 35 over 12. We get here the same answer, 35 over 12. And therefore we say, if you remember these rules, and you know that the problem is discrete uniform distribution, then it is easier to use these rules, but you have to remember them by heart. They are not given in the formula sheet, you have to remember them by heart. Right? These are examples about the cases we explained. Now, if in this case, for example, I was asked, right, to get what is the expectation of 2x plus 3, then I say this is exactly equal to twice the expectation of x plus 3. We using this rule is given rule. And if I was asked what is the variance of 2x plus 3, then the rule is 2 square times the variance of x. This is in that previous question. Now, this is the end of the topic of discrete random variable. Right.